Welcome to Namibia, a glittering jewel in the crown of the African continent. This beautiful country, affectionately called Land of the Brave by its inhabitants, is situated on Africa's southwestern tip. Characterized by wide open spaces and natural splendor, Namibia is well known for its rich fauna and flora and for the Namib Desert, regarded as the oldest desert in the world at more than 50 million years of age. This shifting sea of sand might seem desolate, but wild horses, ostriches and oryx all live here. Look closer, and small reptiles and insects will catch your eye, which is why the Namib is referred to as the living desert. It's not living creatures, however, that rule this land, but the wind, powerful enough to move and shape the rolling dunes towering like mountains. Since time immemorial, mankind has battled nature's elements for dominance, often to no avail, and remnants of this power struggle still remain. A decision to harness the power of the wind, however, instead of opposing it, resulted in a historic Namibian project by Sun Energy Holdings to build the very first local wind farm in the town of Luderitz to generate power. It's called Ombepu, which means wind in the Oshivambo language. Sun Energy Holdings received a license from the Electricity Control Board of Namibia, ECB, to generate electricity using the power of the wind through the ECB's Renewable Energy Feed-in Tariff, or REFIT program. A total of 14 power purchasing agreements were issued to various independent power producers to help increase local energy production within Namibia, therefore reducing the dependence on imports. The Ombepu wind farm project required a capital investment of 180 million Namibian dollars, partially procured through a loan from the Development Bank of Namibia. Unique projects often encounter unique challenges. Deciding to build a wind farm is one thing. Deciding where to build it is another.
We've spent quite a lot of time since the founding of the company, 9 years back, collecting a lot of wind measurement data all along our coast, where we were suspected that there might be very good wind. And we finally saw that the best resource and the most accessible resource is right here in Luderitz. We've got over 2 years, in some places even 3 years of data that illustrates an incredibly good, reliable resource of wind power.
According to all the data collected, Sun discovered that Luderitz was the ideal place for the wind farm project. It was discovered that Luderitz was one of the best sites in the whole world to erect a wind farm, due to the fact that Luderitz was not on an island or located offshore.
It's not just about the strength of the wind, but it's a whole set of factors. It's about the reliability of the wind, the predictability of the wind. For all of those reasons, we've really hit a sweet spot in being able to build a wind park here.
And to top it all, Luderitz is a harbour town. That means that all the components for the wind farm could be shipped to its destination. The Ombepo Wind Farm project holds a myriad of opportunities for both the Luderitz Town Council and the residents, known as Buchters. Physical construction of the wind farm required meticulous planning. 3 different sites were identified, situated on the outskirts of the town. Now the massive task of clearing and preparing the building site was the next challenge. Special access routes had to be created to move equipment up the mountains to the site.
So the first few months is actually just a road project in essence, and building the large storage platform around the top.
The next step was to build the foundations that will root the tower into the ground, comfortably and safely for the next few decades.
And that requires a lot of cement trucks. We've had to actually bring in a batching plant, which is basically a small concrete factory, into Luderitz, and we had to mix our own concrete here on site and drive between 55 and 60 loads of concrete into our foundation here on site.
Once the foundations were completed, the focus shifted to the harbour, where all the components which arrived via sea were stored.
These massive components needed to be transported onto site, so that required a lot of logistics and very specialized trucks, as well as collaboration with the various roads authorities as well as police inside our town to bring all these components safely to site. In most of those were in abnormal loads.
And throughout all these activities, it was as if the wind was trying to oppose all activities, the ongoing battle between nature and human beings. Once the construction components were on site, a massive 750-ton crane, assisted by a 170-ton crane and a 95-ton crane, were brought in to collectively start lifting the wind farm's gigantic components into place. Once again, nature intervened. The abnormal load, which the transport truck was supposed to carry uphill, was too steep for the truck. The 750-ton crane was assembled at another area and then driven up by itself to the different sites.
I haven't done a thorough amount of research on this claim I'm about to make, but it could be the biggest crane that has ever been inside Namibia. That's actually land-based, not ship-based. It's a mobile crane, and this is what we'll be using to actually lift the entire wind turbine into place. Just to give you some specs on this crane, it's quite impressive. It's had to come in on 12 separate trucks. So that was quite a logistical effort. And what we're currently busy doing is we're busy building the entire boom out here, which will then eventually lift up into the sky. I think at its total height, it'll be standing at 96 meters above the platform on which we are standing right now. If you look at the back of the crane there, you can see a bunch of counterbalances. Each one of those steel blocks is about 10 tons. So just on the back there, we're going to be reaching several hundred tons worth of counterbalance. Right at the bottom, we've got the foundation ring. So the foundation ring is essentially the most important root, structurally, the root of the entire tower.
The foundation ring is a 14-ton steel cylinder with long spikes sticking out at the sides. It looks like a hedgehog and is cast into 750 tons of concrete, which roots the tower into place.
The top flange, which is basically where it's the top surface that this foundation ring creates, had to be within 1 millimeter tolerance, because if it's out by more than that at the bottom, it could be out by meters at the top, and that causes havoc for your stresses and so on. So it is incredibly delicate work, even though it's such a massive piece, to try and get it nice and level.
Next on the list to be installed were the tower sections. The tower sections consist of 3 massive cylinders, the first one weighing in at 66 tons with a length of 20 meters.
Then the next one is a little bit longer but lighter because it gets narrower and narrower. And finally, all 3 together is 80 meters high, these 3 cylinders together, and that is essentially the tower. And that's also how we access the top of the tower. Inside is not a staircase, actually a ladder. So our operations and maintenance team that's going to have to climb up and down these ladders on a regular basis are going to have to be very fit.
At the top of each of the towers is a 24-ton piece of equipment called a nacelle, which contains electronics that, amongst others, determine where the wind is coming from and turns itself towards the wind as it changes for efficiency.
On the front of that nacelle is then probably the heaviest component on the entire lift. It's a just under 70 tons generator, and that is where the money is. That's the most expensive piece, and it's also what actually generates the electricity from being turned. And it's quite interesting. It's covered, it's got a slightly silver color, and it's completely covered with heat dissipating ribs, or we call them HDR, and it's aluminium little ribs like this that basically allows any heat buildup inside this generator. As you can imagine, it could create a lot of heat as that thing is spinning, as the blades are spinning, and that passively allows for this generator to cool off. In front of the generator is then basically the final part, is what we call the rotor, and that's a combination of the hub as well as the 3 blades that stick out of the hub. We like to call it on site the Mercedes-Benz sign, if one can just visualize it like that.
The Ombepu Wind Farm project is the first of its kind, and the hubs incorporate the first wind turbine generations in Africa that don't have gearboxes.
Inside this hub is a whole bunch of other electronic equipment. For instance, it is the point which allows the blades to pitch, so it swivels slightly, so that your angle from the approaching wind is hitting it just right, so that we can get our speeds just right and generate the most efficient energy possible with whatever the wind speed may be. So we use that instead of a gearbox, because these are also Africa's first, from what we know, disclaimer, but this is the first gearbox-less generator wind turbines in Africa, and that basically means that a very important point where there is potential failure in a wind turbine in the long term, because often you'll have a wind turbine have problems because its gearbox starts malfunctioning, and that needs to be removed. But because we have actually removed that, the need for a gearbox, we've gotten to a point where we've actually got a much more robust wind turbine going into the future in terms of operations and maintenance.
The tower's final components consist of the actual blades around the hubs. Each of the blades weighs 10 tons and is 43 meters long. Once again, these massive blades cannot be lifted unless wind conditions are not 100% favorable.
So when we lift that Mercedes-Benz sign, as I was describing it earlier, we have a 20-ton hub in the middle with all those electronic equipments to be able to pitch the blades, as well as the 3 10-ton blades. So it's a 50-ton single lift, but it's also it's about 100 meters of diameter. So it's a very, very delicate lift, and we actually require 2 cranes to be able to do it, so that we make sure that none of the blades touch the ground as we are delicately lifting it and swiveling the blade across like this, so that the bottom of that blade doesn't touch the ground, and that we can release a second crane, take it up and install it against the generator.
Innosun Energy Holdings started the construction of the Mbepu wind farm project in October 2016 and lifted the final turbine into place at the end of July 2017. It's a feat of engineering that Namibia, as a stakeholder, can be proud of.
A wind farm is one of the most affordable and efficient renewable energy sources that currently exists in the world. It's a lot cheaper than photovoltaic or solar, and when you also couple that with the fact that Namibia has got such an amazing resource of wind sitting here in Luderitz, it's such a opportunity for us to develop this and open this for the benefit of Namibia. And it basically means that we are generating our power that we use here in Namibia. And as a Namibian, I think that is very important, because we are importing so much electricity out of South Africa. It's billions of Namibian dollars that we are using on imports, essentially. It's on electrical imports. And we have a very easy solution now to try and take us off of that and keep that money inside of the country and employ Namibians inside of the country with that money. And it's just one more thing that we make sure that we are independent, truly independent from our neighbors, and we are truly secure in our own energy security.
The Mbepu wind farm project stands tall and proud, pumping around 5 megawatts of power into the national electricity grid. But the winds of change are still blowing in Namibia on a national scale through the presence of Innosun Energy. The lifespan of a wind turbine is between 20 and 30 years. The 3 wind turbines of the Mbepu wind farm tower over the town for all to see. A beacon of hope, signaling a brighter future for the residents of Namibia.